Hello everyone. So today we are gonna continue talking about the screws, and the first slide covers the Dislift technique and its goals. The Dislift technique basically means that you first over drill the neocortex with your over drill bit, and then you insert your tissue protector or the drill guide of the under drill within the hole of the over drill, and then you under drill utilizing your under drill bit. This way you make sure that your alignment of the gliding hole and the pilot hole is the same. So you over drill, you just penetrate the neocortex, and you put your drill guide inside the hole of the gliding hole, and then you rest it on the far cortex, and then you insert your under drill bit. This way you make sure that they're both in alignment, because if you do not do this, there is a high chance that the under drill will drift away from the alignment. As you can see here, the under drill is very small and it could bend and exit at a different point. But if you utilize this T-sleeve technique, then there is a much higher chance of getting them into alignment. Of course, it's detrimental to have an exit point that is not aligned with the entry point. What is pre-drilling? Basically, pre-drilling is utilizing a K-wire before drilling to create an easy path for your underdrill, because again, your underdrill is weak. So if you utilize a 6.2 K-wire that's 1.6 millimeter in diameter, it's going to be stronger than your under drill bit. And the goal for this is to create an easy path for the under drill bit. What size K-wire you utilize? It's almost always 6.2. The only exception is if you are planning on inserting a small screw like a 2.0 screw, because the under drill bit of the 2.0 screw is a 1.5 millimeter, while this K-wire is 1.6 millimeter. So it doesn't make sense to utilize a bigger K-wire than the drill bit. So in this case, you can utilize a 4.5 or a 5.4 K-wires, and that's the only exception. So countersinking, why do we countersink? So this screw is not countersunk, and this screw is countersunk. As you can see here, there is the metal bone interface is pretty sharp and a smaller surface area of contact is seen here, while we have here a much bigger surface area of contact between the screw head and the bone. Hence, there is a much less irritation of the soft tissue in this scenario versus that one here where you have the screw head prominent and irritating soft tissue, and at the same time the stresses that travel through that screw is dissipated over much larger surface area here compared to the scenario on the right. So if you countersink, you have a less chance of getting stress risers than if you do not countersink. What is the size of the tip of the countersink driver? Well, the size of the tip of the countersink driver is equal to the size of the under drill bit for the screw. So why do we need to make sure we countersink in the center? So if I countersink exactly in the center of the hole, the screw fits in nicely and no chance of stress risers. But if my countersinking is a little bit medial or lateral to the position where it's supposed to be, as I insert my screw, you can see here the screw is not fitting well and it's not getting sunk into the hole. Hence, you get chance of getting stress risers. So it's always very important that you countersink exactly in the center of the screw insertion path. So countersink and overdrill, or countersink and underdrill first dilemma. Which one goes first? Overdrill, then countersink, or underdrill, then countersink? Well, it doesn't really matter if you have a fracture that is parallel to the bone surface, because the screw will be exactly perpendicular to the bone surface and also perpendicular to the fracture. And you can easily insert your countersink in the center and do the process of countersinking. The big problem is when the fracture is oblique to the bone surface, which is a lot of cases, then if you utilize your overdrill first before countersinking, you will not be able to place the countersink exactly in the center, because again, the tip of the countersink here is exactly equal to the size of the underdrill. So if you underdrill first, before you over drill. And if you under drill first, then you countersink, then there is a much easier way to countersink because the tip fits nicely within the under drill bit hole. But again, let's remember that if you under drill first before you over drill, problem is that you will not be able to place the over drill easily on the same path of the under drill. You might go either a little bit south or a little bit north, and then you've created a different hole. So what do? Do you over drill first or do you under drill first? Well, Podiatry Institute have their modified AO technique that solve that dilemma. First, you pre-drill and then you under drill only the neocortex, just the neocortex. Then now your countersink tip can easily fit into this hole and you do your countersinking. Then you over drill only the neocortex, and then you come back and use your under drill by using the Dislift technique, and then you continue as normal by measuring and then tapping and then inserting your screw. This way you have a much better control over your under drilling and over drilling bits and also over your countersink devices. It might take a few seconds extra, but if this is your compression screw and you want it to be inserted in the optimal position, then it's worth it. The lag screw technique for cortical screws. You drill the gliding hole. This is called over drill, and this is the same exact diameter as the screw diameter. And the purpose of this gliding hole is to allow the screw to spin and not catch or engage the neocortex. Then you under drill the threaded hole utilizing a diameter that is the same as the core diameter of the screw. So if the core diameter of the screw is 2 millimeters, this is going to be most likely the threaded hole diameter. You do your countersinking, you measure, you tap, you insert screw as normal. Countersinking is very important in cortical bone because the bone is very hard. You need to have a very good contact between the bone and the screw head. Tapping is not necessary, however, it makes it much easier for the screw to grab into the bone, but most screws now are self-tapping. The cancellous screws are a little different. You will drill the threaded hole under the drill only if that cancellous screw is partially threaded, of course. There's no need to countersink in cancellous screws because the cancellous bone is weak, and if you countersink, you might actually penetrate the neocortex completely and the screw might sink inside the bone. You measure. Tapping is optional in cancellous bone because it's a much weaker bone and the screw can penetrate easily. You can add a washer if you feel that screw might sink inside the bone, or if the screw has already sunk in the bone, then you remove it, you add a washer, you put it back in. But of course never to countersink and add a washer because it doesn't make any sense. And then you insert your screw. We'll stop at this point and we can continue to part number 5.